Okay, we have here today a really good integral from the UNSW integration meet 2024, round 2, problem 11. We have the integral of x ln x minus ln x over x ln x minus x plus e to the x dx. Okay, when I was doing this on paper, I gotta say I really struggled with it for a long time. And then I was kicking myself when I realized I've done a lot of problems like this that were just in a different form with sines and cosines or something else. The trouble I had was just kind of trying to do things with the algebra. I could never really get this end part to work right until I thought about doing a u substitution, just trying to make the whole denominator my u. So let's see what happens when I do this. We will create the whole denominator as the u because we'd like it if this can work, but it's not going to be that easy because the derivative of this is clearly not this. So let's just see what happens. If I take the derivative for du, we're going to have, here we need the product rule, so this is going to become 1 ln x plus we're going to have the first thing times the derivative of the second. Derivative of ln x is going to give me 1 over x. So this piece here is just going to become a 1. Then taking the derivative here, derivative is going to be minus 1. And then derivative e to the x is just e to the x dx. But 1 minus 1, that's just 0. And so what happens cleaning this up, our du value is just ln x plus e to the x dx. And so like I mentioned before, we've got our du value, but we don't really have that anywhere. So what I'm going to do is just force that to happen. So what we'll do is we'll just put this into the numerator. We'll have our ln x plus e to the x. I'm going to make some more space because we're going to need to add all this other stuff, and then I'll just copy down the denominator. And now from here, what I need to do is I need to fill out the numerator and do it without changing the integral. We need to have the numerator still be this whole thing up here. Now one thing I can do is multiply by a minus 1 in front. That way we've got our minus ln x piece, right? Because this minus times this is going to give me my minus ln x. Then what we've done is we've created a minus ex here. I don't want to change it. So if I subtract that off, now I'm just adding 0 basically. Or if you look at it like minus x plus e to the x, either way, that's fine. Then for this piece right here, I'm going to need this to be a minus x ln x, again, distributing in the minus. And then here, this is going to be a plus x, so that with the minus, it's going to be minus x. But now from here, what I can do is actually split this into two integrals because we know we have this set up with the substitution we did before. So doing this, we'll still have this minus sign out front, and then we'll just bring everything over here. And now dealing with this second part here, what I'm going to do is I'm going to distribute the minus sign back in. So when I distribute the minus sign, now we have a plus in front. Distributing minus to here, this is going to give me e to the x. Then this is going to become plus x ln x. And then minus times x gives me minus x. And then we'll bring over our whole denominator. But now this is where everything gets cleaned up because you'll notice that this right here is exactly the same as this right here in a different order. So then what's going to happen is we cancel this with this. And now over here, we're just integrating 1. But this over here is going to be easy because we already set this up with a u substitution. So doing this, making that substitution, this is going to become minus du over u. And then over here, we just have to integrate 1 dx. But integrating this, that's just going to give me an x minus integral of this is going to be natural log absolute value of u. But now all we need to do is just back substitute in order to finish this off. And so for my final solution of this, we just get x minus natural log absolute value x ln x minus x plus e to the x absolute value, add a plus c, and that's it. Okay, there you have it. Really good problem from UNSW 2024. Thanks everyone for watching. Have a good day.